Hi guys, in this video we are going to see numerical differentiation. Similar to interpolation, numerical differentiation also have two types, that is Newton's forward and Newton's backward. In Newton forward, we have two classification, that is when x is not equal to x naught and x is equals to x naught. These are the formulas we need to use for first, second and third derivative. X minus x naught by h gives the value for n when x is not equals to x naught. When x is equals to x naught, these are the formulas for first, second and third derivative. You have to memorize all these formulas for calculations. When x is equals to x naught, n value need not to be considered in any of the formula. The next type in numerical differentiation is Newton's backward. These are the formulas for first, second and third derivative when x is not equal to xn. X minus xn by h gives the value of n. You could simply remember, like for the first derivative, 1 by h into del yn plus del square yn plus del cube yn in increasing order. Likewise, in second derivative, 1 by h square multiply with del square yn plus del cube yn in increasing order. And for the third derivative, 1 by h cube multiplied by del cube yn plus increasing order. These are the formulas which have to be applied when x is equals to xn. Memorize all these formulas for calculation. The first, second and third derivative when x is equals to xn has to be calculated using these formulas. Now, let's see a problem to understand this concept in a better way. Find the first and second derivative of the function at x is equal to 0.6. Here, the values of x and y will be given in the question. We have to tabulate the interpolation table for calculations. As we already know, del is just the difference of y values, del square is just the difference of del y values and del cube is the difference of del square y values. The first values of the del tables are termed as del y naught, del square y naught and del cube y naught. Whereas the last values of del table are termed as del yn, del square yn and del cube yn. Y naught values are used for Newton's forward and yn values are used for Newton backward. Unlike interpolation, we get two values for del cube. Del cube y naught should be used for Newton's forward and del cube yn should be used for Newton's backward. X minus x naught by h gives the value of n. Here, x is the value which we have to find, that is 0.6, and x naught is the first value of x and h is the difference of x values. Even though 0.6 is at the center of the set, we consider using Newton's forward formula. Using these n and h values and also del y naught, del square y naught, del cube y naught from the interpolation table, substitute it in Newton's forward first derivative formula. After arithmetic simplifications, you will get a value which is the value for the first derivative of the function. Now, substitute n, h, del square y naught, del cube y naught value in the second derivative of Newton's forward formula. After simplifications, you will get the value for second derivative of the function. This problem based on the derivatives of Newton's forward. Now, let's see another problem which includes both Newton's forward and backward. In this problem, they asked us to find the growth at x is equals to 31 and 71. As I already said in the interpolation video, divide the value set into half. And here the value 31 and 71 comes from the first half and the second half of the set. Hence, use Newton's forward for 31 and Newton's backward for 71. Tabulate the values of del, del square, del cube and del power 4. In this problem, we could see that x is equals to x naught, that is, the value they asked us to find is equal to the first value of the set. Therefore, use the other set of formula in Newton's forward when x is equals to x naught. Substitute the values of n, h, del y naught, del square y naught, del cube y naught and del power 4 y naught from the interpolation table. After arithmetic simplifications, you will get the value when x is equals to x naught using Newton's forward. The next value we have to find is for 71, and here x is equals to xn. Thus use another set of formulas in Newton's backward. Substitute the values of n, h, del yn, del square yn, del cube yn and del power 4 yn in the formula. Here del power 4 y0 and del power 4 yn would be the same. After arithmetic simplifications, you will get the value for x is equal to 71 using Newton's backward. I hope you understood this concept in a better way. Given below is the problem you could take for practice, in which for the same problem, find x is equals to 41 and x is equal to 61. The answers are given. Solve and check. Do check description for PDF. Thank you for watching this video. Do subscribe our channel and stay tuned.